Grade 10 learners, physical sciences, I welcome you. We are going to look at electron arrangement. As you can see, I've prepared something for you and it is already on the screen. Here we are looking at an atom and how the electrons are arranged in this atom. First, what I've pointed at here is a nucleus. We know that in a nucleus we find the proton and neutron. And then we have levels or orbitals. This is the first level or first energy level, second energy level, third energy level. The black dots here are representing electrons. The first shell requires only 2 electrons. It occupies only 2 electrons. The second one can take up to 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Even the third one can take up to 8 electrons. But in this example here, I've put only 2. So I said the first shell requires 2 electrons. It is filled by 2 electrons. If you have more than 2, you cannot put 3 here. It means that the rest will go to the next shell. This next shell requires 8. If you put 8, this shell is filled. You cannot put more than 8. Like what I've done here, 1, 2, 3, 4, 5, 6, 7, 8. Even the third one requires 8. But if you don't have 8, the remaining one will be filled in this one. Like what had happened here, I have 2 electrons only. So the electrons that are found in the outer shell are called valence electrons. This one are called valence electrons. In this example, I have 2 valence electrons. So let's go to examples. Let's go to examples and see how we can fill the electrons of different atoms. The first example that we're going to look at is a chlorine atom. What is it that one must look at before filling the electrons in these shells? You look at the atomic number of chlorine in a periodic table, and the atomic number of chlorine is 17. It means that you are going to put 17 electrons in this chlorine atom. You start by filling the first shell, which requires only 2. If you have 17 and you put 2 here, it means that what is left is 15. Because the first one requires only 2, you move to the third one after filling the first one. In the second one, not the third, in the second one, you are going to put 8. 1, 2, 3, 4, 5, 6, 7, 8. You don't have to put more than that. 8 is what is allowed to put in this shell. Now you have used 10. You have used 2 in the first and then 8 in the second shell. The remaining one must go to the next shell. If you have 17 and you have already used 10, you are left with 7. The remaining 7 will be put in the third shell. 1, 2, 3, 4, 5, 6, 7. We know that this shell requires, or to be filled, it requires 8 electrons, but now it contains only 7. It means that in order to fill this shell, we need 1 electron to fill the third shell in this chlorine atom. So I've already said that the atoms that are found in the outer shell are called the valence electrons. Let's go to the second example. This one is neon atom. The atomic number of a neon atom is 10. So the electrons that I'm going to use to fill these shells is 10 in numbers. The first 2 will be taken by the first shell, and then 8 will be left. Then we put 8 in the following shell. If you add all these electrons that I've put here, they bring us to 10. If the outer shell is filled with 8 electrons, it tells us that this atom is stable. It tells us that the atom is stable because the outer shell is filled. It doesn't need any electron. Neon atom is stable. The previous one, which is chlorine, we found that in the outer shell we have 7 electrons and it needs 1. It makes it less stable. Let's go to the next example, which is magnesium ion. Magnesium ion, Mg2+. What is the atomic number of magnesium? It's 12. Atomic number of magnesium is 12. But here we are given magnesium ion, not magnesium. We know magnesium, that atomic number of magnesium is 12. In this case, we are given magnesium ion. So what does this 2 plus tells us? It tells us that magnesium has lost 2 electrons. If magnesium has lost 2 electrons, it means that we no longer have 12 electrons. We now have 10 electrons because 2 had been lost here. So when we fill the shells here, the total number of electrons will be 10. We know that the first shell will take 2, and then we are left with 8. The second one requires how many? 8 electrons. Here they are 1, 2, 3, 4, 5, 6, 7, 8. Including these two, they give us 10.